First thing I ask you guys to do is find your critical values. When you guys find the critical values of a function, you need to find its derivative and set its derivative equal to 0. And sometimes you also need to find out where that derivative is also not defined. But in this case, when you take the derivative, because the derivative is another polynomial function, you probably know that that polynomial function is defined everywhere because it's a quadratic.
12x.
Almost forgot the x.
Oh, no.
Okay. Now this function is given boundaries, endpoints, but we're going to deal with those in a minute. We don't need that yet. So we're going to take this guy and set him equal to 0. So 3x squared plus 12x plus 9 equals 0. It looks like everything is divisible by 3, which is good news because now we have a positive 1 in front of the x squared. Okay, we got this now. Now in order to solve this, I need to... oh, is that right? Yeah, that's right. No, did I just...
Yes.
No, that's right?
Yes.
Okay, I get x plus 3 and x plus 1. That's where we would equal 0. And I get x equals... negative 3 and negative 1. Okay, these are critical values. Done. Okay, now what are critical values, guys? Critical values are where you could possibly have a max or min. Okay, critical values is where the function has a slope of 0. A slope of 0, like the tangent line. So right here and right here, we know the x value here is negative 3. And right here, we know the x value is negative 1. But we don't know the y value. We also know the x value of this point right here. And we know the x value of this point right here. Do you guys know the x value of this point right here?
Negative
the first
5.
one. Oh, negative 5. Negative 5. And the x value for the second one is negative 1/2. Okay, so it says find the relative extrema. Now, relative extrema is the same as local extrema. I think there's another word, but I can't think of it right now. Relative and local. Okay, so what we're going to do is you're going to plug in the negative 3 and the negative 1 to find the y value. Now, we have two different functions that we can plug the negative 3 and the negative 1 into. Are we going to plug those numbers into g prime or into g in order to find the y values for these 2 points?
G.
Yes, we're going to plug them into g. This is very important that you guys make note of that because we make these mistakes all the time with which one we are supposed to plug it into. So if I plug negative 3 into g, what do I get? Let's see, we get negative 3 raised to the third power plus 6 times negative 3. And writing this all out is actually very annoying. I actually hate it. But it's worth your time. You guys should do it. You should always write out everything when you guys are taking a quiz because then you won't make errors with negatives. Okay, so negative 27. This is going to be positive 9 times 6, which is 54. And then we also get another negative 27. Negative 27 is going to be negative 54. And then we have a positive 54. So what do we get? We get 0. Hey, how nice is that? That's 0. That's right on the x-axis. All right, we do this again with negative 1. And what do we get? We get negative 1 raised to the third power plus 6. Negative 1 raised to the second power plus 9 times negative 1. Negative 1 plus, this is going to be a positive 1, so it's going to be a 6 plus negative 9. And so our solution, or our y value here, is going to be negative 10 plus 6, which would be negative 4. So our y value here is negative 4. All right. So we found the relative extrema. The relative extrema are, what are negative 4, or 0, and negative 4. Maybe I should say and. 0 and negative 4. Remember, those are the y values. Our critical values are negative 1 and negative 3. Absolute extrema. Okay, now you guys have the graph in front of you. Most of the time you don't have the graph in front of you. Because the graph is in front of you, you can easily see what your absolute max is. What's our absolute max? It is 0. And you can see it because we have the graph. So because we have the graph, we know that 0 is going to be an absolute extrema. Which absolute extrema is it going to be? Is 0 the absolute max or the absolute min? Absolute max, for obvious reasons, right? You're looking at it, you're like, oh yeah, this is a local max, and also this is the highest point. This point is lower, this point is lower, and this point is lower. Okay, but what if you didn't have the graph to look at? What would you need to do?
Find the other two.
You got to find the other points, right? You got to find this endpoint and this endpoint. Now, this one, because we have the graph, I know you don't want to do it. Because you're like, well, it's neither a max or a min. Because this 0 is higher than whatever this is going to be. And this -4 is going to be lower than whatever this is going to be. But if you didn't have the graph, you would have to plug in every critical value and every endpoint. The only way you would get away with not having to plug it in to all of them, plug in all those points, is if you actually can see the graph. Okay, so we got we got 0 for that one. We got -4 for that one. -5. Oof, I really don't want to do this. All right, so we have -125 because we had the qubit. This is going to be positive 25 times 6. Do you guys know what 6 quarters will give you? It'll give you 150, right? Right? Yeah. Okay. Sorry, just getting off a break here. And then we have 9 times -5, which would be -45. And so if I add all those together, this would be a total negatives of 170. There's 170 negatives plus 150.
20.
So we get -20. -20 is what we get when we plug in -5. Okay. Now let's plug in the -1/2. Ew. Okay, so we get -1/8 when we cube it. Well, this will be 1/4. 1/2 times 1/2. -1/2 times -1/2 would be 1/4 times 6. So this is going to be 6/4. And then plus 9/2, but negative, right? Because it's a -1/2 that we'd be plugging into the x. All right, taking a few shortcuts here. I can make this into a 2, and that would make this into a 3. I'm going to add the two fractions together first. 1/8 plus these two fractions, because they have the same denominator. That would be a -6/2. Yep. And then if I add those together, I'm going to make the 2 into an 8. So I multiply this by 4, it'd be 24. It'd be -25/8, which as a mixed number would be -3 1/8. So that's what this y value would be right here, -3 1/8. All right, and now, just by looking at the y values right here, we can see what are our absolute extrema. Okay, what is our absolute max? 0. What's our absolute min?
20.
-20. Okay, they are y values. All right, so last thing on the agenda, or the question, says intervals of increasing or decreasing. Now, again, we're kind of cheating because we have a graph right here. We can easily see where this guy is increasing and where G is decreasing. Okay, there's 2 intervals where we're increasing and 2 intervals when we're decreasing. Okay, but what if we didn't have the graph? I know, you guys are like, whoa, now you're going to make me do more work. Okay, just to make sure you can see it, this is the interval of increasing. Here's another one that's increasing. And then we have our decreasing right here. Oh, wait, come on. I'm trying to draw here. Where we go? Okay, so that's their interval of decreasing. How would you know this? How would you be able to figure this out without having the graph? Because sometimes it's not practical to do the graph. There's a faster way to do it.
I don't remember what it's called.
Okay, so here is how you can use your derivative to find intervals of increasing and decreasing. I like to use something called a sine line graph. And it's a nice, healthy tool that you can use to help organize your thoughts here. Now, what we do on our sine line graph is we put the critical values. So it's -3 and -1. I'll put the critical values on that. And then, as you can see, before the -3, we're increasing the entire time. Between the -3 and the what is that? -1, we're decreasing the entire time, and then we're increasing. But what if you didn't know this? Okay, that's what we're trying to do. What if you didn't know that? How would you know if you're increasing or decreasing? Julia mentioned, well, if you know the absolute max and absolute min, or the relative min, relative max, you can figure it out that way. Yes, you could, because you know from going to -20 to 0, you would have to be increasing in this interval right here. Okay, that's one way to do it. Another way to do it, there's two ways. I'm going to write them down. You can use tester points, or you can curve sketch. Both of these are skills that you guys learn in Algebra 2 Trig. Okay, tester points. This is what you do. You make this x-axis that you're making here for G prime. Oof, that's a nasty G. For G prime. And what you're doing is you're trying to find out if you're below the x or above the x-axis or below the x-axis, above the x-axis or below the x-axis, above the x-axis or below the x-axis. Because everywhere G prime is above the x-axis, you know that you're increasing on your graph. Okay, so we know, because we have the graph, that this is going to be positive right here off the bat. But how do you use tester points to know that? What you do is you pick a number that is in that interval. So my tester point is going to be -4 here. My tester point is going to be -2 right here, and I'm going to pick 0 right here. Okay, you pick an x number that's in that interval, and then you plug it into G prime to see if you're positive or negative. Okay, that's how you would do tester points. Okay, now I'm just going to do one of them. I'm going to do the easy one. Plug in the 0. What do I get? 9. I get 9. Remember, we're plugging 0 into this. That would go away. That would go away. We get a positive 9. So I would know that we're positive right here. And that's what you do. You test the -2. You plug it in to see if you're positive or negative. You plug in the -4 to see if you're positive or negative. The other way I want to talk about is curve sketching. Someone just asked the question, can we use 0 even though it's outside of this? And the reason why you can is because both our critical points are inside of them. And usually, guys, when you guys get the question of increasing and decreasing, it doesn't give you the endpoints. I gave you the endpoints because I wanted you guys to find the absolute extrema with endpoints. Sometimes we don't find the absolute extrema with endpoints, but most of the time you have endpoints when you do absolute extrema. So the other thing to do is curve sketch. And remember, for both of these, you're doing this stuff with G prime. So you're curve sketching with G prime, or you're doing tester points with G prime. Now, if I'm doing curve sketching, this should be super easy for you guys, because you're looking at this guy right here, and you know what this guy looks like. He's a parabola. He looks like this, and he's facing up like that. He's not facing down like this, because you know that the leading coefficient is positive. So because we know that this graph would go like this. And we know that we would be positive, negative, and then positive. And that's actually exactly what's going on right here. We're positive slope, negative slope, positive slope. Remember, this is the graph of G. This is not the graph of G prime. Okay, and that's how you do it.